Okay, and recapping our mnemonics that we used today. Okay, so we talked about our job as a data analyst. Remember, we were sitting down at the desk, brown, well, my desk was brown, what color your desk was, but we were sitting down at our desk, whatever color that may be. Really, our first step is figuring out where we want to go from here, right? We want to look out and explore this data analysis or data so that we can understand our distributions and help use our distributions to help guide our analysis. Where do we want to go from here? We talked about we had that picture up on our wall to help us remember what really our goal is to provide summary statistics. We need to be aware of the distributions and how those will affect our summary statistics. Our business partners are not maybe going to see those distributions, they might not be aware of that, but we really want to make sure that we're delivering valuable information that's not skewed in any way that could be affecting their decision making ability. Talked about we heard that noise too, like bang, bang, bang. Noise next door when you're trying to do our data analysis. Rude people next door doing their hypothesis test, but I understand it can be kind of frustrating and making a lot of noise while they're doing it, right? So a really important step in our data analysis as we deal with the sample, but again, it makes a little bit of noise when you're doing that testing. We talked about we were outside of our house or wherever you might have been when we saw the moon that one day. I was outside of my apartment and I saw all the data falling down from the sky. And it really I decided I labeled that as outlier data. I decided that's my threshold that when data is falling from the moon, it's outlier data. And what we saw is that it started to skew our vision a little bit. It started to make things a little bit harder to see. So we wanted to be aware of how those outliers, how the shape of our distribution is the skew could potentially skew our distributions, our summary statistics, our interpretations. And we had our friend that was coming up, one of our old friends was coming up to say hi to us, and he was a little bit blurry. It was a little bit hard to see him, and we were a little bit worried because of this all the data that's skewing our vision around us. We're a little bit more concerned. We have to be very clear, and we want to try to make clear and concise communication with this because it is might be affecting the relationships in our data, and so we have to be careful about the skew and the shape of our data. Those outliers can be really tricky. We discussed that really what we're trying to do is make an inference on the entire population as a whole. Okay? We have a small sample. We're trying to understand the whole population. We often do this, or a good starting point in our data analysis is the histogram that gives us a good sense of removes a little bit of the noise and helps us approximate more the shape of the distribution. The noise can be good, but that much detail usually is almost unnecessary. We want to understand a bigger picture type of understanding. The histogram helps us do that well. Although not always. Sometimes you want to understand less detail, and we'll talk about that in later class. How we can get really that high level of detail. We talked about different types of distributions. We had an equally likely occurring type of distribution. Do you remember which one that was? That's right, the uniform distribution. We also had a distribution that was symmetrical. Do you remember what type of distribution that was? That's right, the normal distribution. We also had one with a long right-hand tail that, remember I said many times, not my favorite distribution to deal with. Do you remember which one that one was? Right, the exponential distribution. And then we had a distribution. We often look at the balance in the category. Kind of give that one away, but do you remember which one that distribution was? Right, the categorical distribution. Which one? And really understand really the big four main types of distributions, and we'll use those to approximate shapes. When we're trying to describe our distributions, we'll use those to approximate the shapes of our distribution. Okay. We talked about what to understand from different distributions. When we had a uniform distribution, and when we see really things that didn't make sense, it's time to say, sometimes we can get really far with data analysis, but there's going to be a limit. And so it's very humble, and we want to say, it's time to talk to an expert really to understand this in a little more detail. We talked about a normal distribution and how, talked many times already, how we said about the outliers that often occur in a normal distribution. We have tails and how they can really pull, like this outlier gentleman right here is pulling the mean so the mountain and the moon towards him, outliers will really have a large effect in pulling statistics towards them and adapt to what works for the outlier, sacrificing what really the bulk of the data would provide. We talked about how to deal with log distributions exponential distributions, and we can take the log transformation of those, which would turn an exponential distribution back into a an exponential distribution back into a normal distribution, which is much easier to deal with, can give us a better statistic. A normal and an exponential distribution can be a little bit deceiving in the answers we're seeing, good or bad, but what we're seeing is when we do a normal distribution and a log transform exponential distribution, so they're much similar to both being normal now, we get a much clearer representation of that correlation. We do other things like bucketize and put our exponential into buckets and remove the effect completely of that long tail. We did touch on what outliers are and how they are in the box plot. We have our mid-range of data, our interquartile range, which is the 25th to the 75th percentile, and 1.5 times outside of that is our classic definition of an outlier. And it is really good because we'll see in later classes the effect of the way that we manage our outliers can have on our summary statistics. And so it can provide a little bit of skepticism about your data analysis if you're doing a little bit too much to massage your outliers, because as you will find out, you can really massage them to give you a good answer or a worse answer. And so it's good to stick with this classic definition unless you have a really solid reason as to why. And some of the things that we talked about, the mnemonics that we used, unique, illogical, lots of colors. We connected everything to past memories, time that we saw the moon. And these are really important. We kind of told a story through them. So that will help us draw us back into these points. And I used colors a little bit as well. I find colors have a little bit less, but they're there. They're there to kind of draw us back and make it easier to find memory. And the thing is, you won't really notice these. The information will just be there like it should be. Use words association to help connect those two, give us a little aid in coming back to those memories. Talked a lot about location and space when I was telling stories. I really kind of talked about there. Really using 3D space, and that's just how our minds work. We remember things a little bit better when they're 3D spaces. I wanted to mention that there was a lot of writing on the slides that I didn't read that, and so it would be really good if you could go back down with the slides or go up and view all the slides that this class, read them a little bit and make sure you understand the concept. But just by going back through this one more time, you're really going to lock these things in your memory. And hopefully, again, with these mnemonics, all these memory devices, you'll be able to find that information even easier for many, many years to come. Okay. Thank you so much for joining me for the second class, and I'll see you in the Python notebook.